Hey YouTube, it's JP Dillon. Welcome to part 2 of the Magnavox Model 300 receiver. In the last video, we repaired the left channel amplifier, which had failed due to a failure of the bias regulation diode. We replaced that, replaced an emitter resistor, and since the previous owner had already replaced the output transistors, we were good there. But then we noticed that there was a discrepancy in the preamp output, and that was true at the input of the amplifier. And you can see the discrepancy right there. The left is much louder than the right. Now, the first thing you can do to validate that this is truly a preamp problem and not an input circuit problem is we can switch in the mono, and we can see switching between mono and stereo has no effect. Also, turn the volume all the way up so that there is no loading of the volume control for the input circuit, and reduce your signal. So in this case, regardless of whether it's at minimum or max, the discrepancy remains, so we know it's not a problem with the tracking of the volume control. So that leaves either a component failure, like the balance control, or a component inside of the preamp itself. Now, before everybody runs to the recap, capacitors usually affect the frequency response of a preamplifier. And if the caps are bad, with that loss of gain, you will also have a loss of linear frequency response. So, if we change the frequency of the signal being fed into it, right now we're at 700 hertz. Let's go to 7,000. We see that the difference remains the same. Let's go to 10,000. Again, the difference is the same. Let's go to 100. Adjust our time base and look, it's the same. So frequency response does not play into this. And so therefore we can probably rule out it being a capacitor. That's not to say that it isn't, but given that information we have, the probability of it being a capacitor is very small. What we have to look at is something like the balance control not being linear anymore, in which case we can usually pad the side that's a little bit less resistance to kind of even things out. We can also check and see if the gains of the stages are the same, which could mean a bad emitter resistor on a transistor that's gone up in value, a defective transistor itself, although I don't see any evidence of noise or anything, so probably not a transistor. So then the other problem is that the way that this machine is designed precludes real troubleshooting of the preamp, because this is the component side of the preamp, and that is the solder side. And you can see the majority of the solder side is completely blocked by the lamp housing assembly. Now, it may be that we can take that back a little bit, but I don't think so. I think looking at this, the only thing that's movable in this scenario is the PCB that's attached to the back of the lamp housing. I don't think the lamp housing is movable because the tuning and everything is attached to it. So that makes it somewhat difficult for us to get any sort of test equipment or probes in here. So this is going to be a fun one. What I'm hoping for is that the balance control itself is actually defective, because that's an easy thing to work around. You add some trimmer resistors in parallel with the circuit that's excessively gainy, and you can trim it out a bit so that the center point of the balance control is really the center of channel, and it makes it a little more linear in its control. So the first thing we have to do is some basic testing and see where the discrepancy is in the preamp and what probabilities there are that could be causing that discrepancy. So not a very fun one here, but everybody is quick to say, oh, just recap it, just recap it, just recap it. The disassembly time that would be needed to recap this machine would be huge. This board's easy. He's done this board because everything is right here. However, this one would require that you de-string the tuner, take the lamp housing and the front panel completely apart, undo all of these board clamps and everything here, and pull this out and replace everything. And this machine really isn't old enough, nor does it have known crappy capacitors. These Nichicons are pretty good. They're not the United Chemicons, they're not the Elnas, they're not the Panasonic Pissers, they're not any of those that have a tendency to fail drastically. So, enough rambling. Let's get to it. Now, of course, the first thing somebody mentioned in the last video was, well, why not just clean the balance pot? Okay, I'll do that. Let's go ahead and clean the balance pot. And we'll see if that makes it happy. And so we'll bring this back up to center again. But alas, no joy there. So maybe we have a problem with the tone control. But again, our tone's not affected by it. So yes, we can clean these, and they are noisy. So we'll do our treble control, and then we'll do our bass control down here. But that ain't gonna do it. And again, still the same difference in gain here. Now, let's compare inputs. Let's see if we have a problem with another input. So if I move this from the tape monitor to the phono, let's go ahead and turn this way down, and we'll select our Mag phono input. Yep, looks the same there. And let's see what happens when we just go back to the regular aux input. Probably going to be the same thing. Yep, certainly looks the same there. And just for grins and giggles, I think there we go. It's got one of those auto mute things. Let's crank that up. Yep, crummy on the radio too. So that absolutely determines that our problem is in the preamp, and it's regardless of any input there is. Now, the way that these typically work is you have the volume control, which attenuates the input, and then it goes to the balance control. So one way you can tell if the balance control is at fault is you can measure the input resistance with the machine off, of course, but we'll take our meter and we'll measure the input resistance between left and right with the balance centered and the volume all the way up. And we'll see if we have a resistance difference between the input and ground. Now that will tell you that there's a nonlinearity in the balance control, in which case we can usually shore that up with some split resistors, and that will make it happy. Of course, that's not to say that trimmer resistors in the balance circuit here are not to blame either, because that's a section of the preamp, and we could have an emitter resistor that's off kilter or whatnot. But first of all, let's measure the resistance. Alright, so I have my probe here. We're going to go up to the auxiliary, and here is the right channel. Looks like about 478 ohms. And the left channel, much higher. Of course, we're bleeding down here. That's just going through a capacitor. Still higher though. That looks like 535K. So a higher resistance. And that looks like about 480K. So there is a significant difference. Now, if I can leave the probe in here, I don't know if I can. Let's adjust our balance control. Which is doing nothing for our input. It keeps charging and discharging a capacitor, so this may or may not work as an adequate measurement here. Of course, the next thing we can always do is actually go to the different legs of the balance control over here, and we can look at this leg here, which is about 9K, and this leg here, which is 26K. Is that right? Wow. That's a difference. Yep, there's 26K on one leg and 12K on the other leg. And then the center tab's usually at ground. Yeah, we're at ground there on the center tab. So, wow, that's a difference. And if I spin the balance control over, we see that change. And so what I'm trying to do is adjust the balance control so that we have equal resistance on both sides. Just need to be able to hold my probe still. So we have about 14 there, 21 there. Let's back that off a little bit. So we have about 20 there. Oh, needs to come up a little. 17 there. 19 there. We are sure getting close. 18 there. 18 there. Okay. So now the balance control, which is at the center point, is absolutely centered. So that control's good. So when the balance control is centered, we have an absolute, let me put the signal back in here. We have an absolute centering of this balance control here. So the control's okay, but we still have an imbalance. So we can rule out the control. That's for sure. Now the next thing I can do is we can check the volume control, although I don't think that's going to be it either, because we don't have a change when we move the volume control. And so if I crank up the gain here, we see that even at the minimum part of the volume control, that imbalance still exists. So it's probably not the volume control, although we are going to test it just because. And so let me move stuff here so we can kind of get at this. This is what real troubleshooting is all about. It's just elimination of what isn't wrong. Okay, so we're going to go to the high side of the volume control, which is here. This is one channel, which is 595K there, and I can't really even get to this side here. I'm measuring the loudness tab. Let's tilt this back a little bit. Now I can kind of get to it here. 595K there. So the shunting resistance to ground for this control is the same on both sides. We got 7 ohms off ground there, and I can't even get to this one here. 7 ohms off ground there. So this volume control and the balance control is perfect. So we can absolutely eliminate the defective balance control, and we can absolutely eliminate the volume control. But the input impedance at the rear of the set varies enormously. If we go back here, we disconnect our signal generator, we can see a capacitor charging there to about 478 ohms on one channel, but on the other channel it's significantly higher. Look at that. That's 545K. So the next thing that we have to realize is that there's a commonality between all the inputs and the outputs, and that is the loading for the record out for the tape monitor, which also is in the preamp circuit. So if we come over here and we take a look at our, let's see, our tape record out and follow where that goes. Let's see if it's true that the resistance at the record out is differing. I bet it is. So on one channel here, we have, come on, get a clean connection there. The terminals are so crusty on this thing. I don't think people use the record out on these. All right. See, there's our point of commonality, our 478 on one side, and then our 500 and something on the other. So let's take a look at the record out and where this comes from, because there has to be loading there. And that's the dark brown wire, I think. Let's just double check here. Yeah, that's the dark brown coax that's coming up here. So that's going to terminate here, and let's validate that. Let me put this down for a second. Okay, so we're going to check again. So this should be ground, and it is. This should be, yeah, there's our 500 and something K there, and then charging up. Interesting. Okay, so we have 544 here. Okay, there we go. Back to our 478. All right, so now we take a look at the tape monitor switch, since that has to go through it. Let's see if switching in our tape monitor switch has any effect on the loading of this circuit. Now we got 29 megs there, but we only have 16 megs there. Is that equally the same on both sides? Yeah, so this is lower no matter what. So we go from 479. That's varying enormously. Look at that, it's all over. So I wonder if this switch is to blame for our problems. Let's find out. So let's go ahead and plug our auxiliary signal back in. Let's turn this on. And there's our discrepancy again. Yeah, it's, you know, it's dirty, but I don't think the switch itself is the cause, because cleaning it up doesn't solve anything. Okay, so that's not solving anything. The next thing we're going to look for are loading resistors, like these guys here, and see if their values are still what they're supposed to be. All right, so looking at number 1 here, we've got 122. That's kilo ohms, and the other one we got 118. That ain't going to change anything. So, really, somewhere in the record out circuit is where our problem really lies. Now, we can tear this apart and we can troubleshoot this heavily. But in the interest of getting it out the door, and in the interest of the fact that it is a garage machine, and I don't think he's looking for ultimate high fidelity, what I intend to do is take the side that has excessive gain and trim it down some to try to match the impedance of both of these legs so that they're both the same, because one is significantly higher than the other. I believe it was this side here that was higher than the other side. Yeah, that's like almost 600K, and this one's 478, 479. Now, wait a second. 595 and 594. Okay, so it's the same now. So now that it's the same, is our channels the same? They're not. Still not. So we can now exclude the tape monitor. Now that we've cleaned the switch, the record output and everything is equally balanced, and so that's not it. Darn, that would have been simple, wouldn't it? Add a trimmer resistor and you're good to go. So we literally have double the gain here. And again, if y'all are curious, we can go to the power amp input, and I can show you that the difference is in fact there. And that just means that I need to adjust our gain here. That's one side of the input. That's power supply. And that's the other side. They're obviously role reversed here, because if I go back to the correct channel allocation, come on, we can see that that channel imbalance still exists. Get the probes to hold on there, and we can see that the gain is a little bit different there, but not much. It still exists, and I could also be on the side of a loading resistor, so trying to get a spot here. That's pretty close. At the input of the power amp there's still a difference. Now that also makes one wonder if the loading on the power amp is correct, but that's easy enough to find out. Wait for that to bleed down, so we assume there's no voltage there. Probably going to take a bit. So let's look at the input to the power amp. And these are loading resistors here. Yep, there's still a voltage there, so we're going to have to wait until that bleeds down, because I highly doubt they'd have an 11 meg input circuit there. 8 megs, nope. Let me just discharge the power supply real quick. Sorry about that. And this is just using a big fat 8 ohm resistor to ground. Bleed all this down. Can't see it on camera here, but I'm going to touch all these points that would have voltages on them from the transistors. I'm essentially just using my speaker load box as a means to bleed it down. Alright, so let's try this again. And let's look at our input load here. These are the loading resistors, which are 47K there. That's about what I would expect. And then this other one here, 54K. Interesting. That's a bit of a difference. But is it enough to matter? And let's go here. Yeah, see there we have 9 megs to ground. 10 megs to ground there. Come on. Yeah, 5 megs to ground there. So either we have a voltage left here. We do. Still have a voltage to bleed down. All right. Let's make sure that's bled down all the way. And then what we'll do is switch back over to ohms and release it. And it's just charging that capacitor at the input there. But, interestingly enough, this loading resistor at 47K is normal. This loading resistor is at 54K. Cool. So, is the side with the higher resistance the one with the larger signal? In which case, we just might simply not be loading down the power amp correctly, because the preamp does look into this load. And so if we look at that there, that's about 4 divisions versus the other side, which is 3.5 divisions. So what happens when we change this resistor so that it properly is 47K? Let's find out. So I've got my fresh 47K. We're just going to validate that it's actually 47K. 45.6 or whatever. Of course, I'm reading across myself, so that's going to mess with things. 46.8 looks about like 47. So let's go ahead and desolder the old resistor. And just on a side note, have y'all seen the cost of solder wick these days? I'm saving my good chem wick. This stuff here. This stuff's expensive right now, like 60 bucks a roll. And I got the MG Chemical Super Wick for now, which is okay, but it ain't the chem wick stuff, that's for sure. Anybody else seeing that? And I'm talking through like major distributors, like, you know, DigiKey and Mauser and stuff like that. They're expensive right now. Don't know why. So, this stuff works okay. It's not great, but it gets the job done. And this giant roll, I think, was like $35 or something like that, which is what I used to pay for the good stuff. All right. So let me get this stuff out the way. And we'll Yankee here, which you're probably not going to be able to see well. Get some hemostats. And we'll pull the old guy out. And there he is. Now I heated this part up, so it might be a little bit closer to what it's supposed to be. We were getting like 55K. Nope, still 55K. That is outside of the 10% barrier. And that significant increase in loading would definitely mean that the preamp output would be a little bit louder. So we're going to place our new resistor in there. And we'll solder it in. And then we'll do a test to see if that significant change in resistance on that other channel that was louder is in fact causing different loading of the preamp. And based that this is a very simple preamp, it could very well. But we won't know until we flip the switch. So let's trim this off. And let's get our stuff hooked backed up here. And let's see how it looks now. Yeah, it's closer, but it's still not quite right. If we overlap the two, we can see that there is a significant change. It's better, but it still isn't right. So now we have to wonder if one of these gain stages here is to blame for the problem with the preamp. So let me go back to my main amplifier output here. And yeah, the change is more noticeable there for sure. And out of curiosity, let's come to the top of the volume control, which is where the signal would originate really. And it's going to be tiny here, so I gotta do a times 10. Yeah, so we're there on that side. So it's actually about the same on the volume control, which is what I'd expect. Alright, so we have one inversion stage here. So that's a little over 4 divisions there. A little over 4 divisions there, but it's equal there. So we're good up to that point. Wow, that's even bigger. Okay, so we got that there. Why am I not getting any change there? Interesting. Alright, so right in this stage, let's see here. So let's check out our collector. That's usually where the gain is. We're good there. And we're good there. So the gain of these two transistors appears to be the same. So we can probably rule out the transistors. Probing this, we see that we have a signal there, which is probably at the output of one of these transistors. If this one here, we don't have much of anything. So I'm not sure if that's significant or not, but that just kind of is. And then we've got these two gain stages back here. This is probably an emitter follower, so let's look at our base. And let's look at this side. Look at our base here, about the same there, about the same there. So these two are doing about the same. And let's come up to this stage here. That's itty bitty. This could be our phono preamp because, yeah, I think that's the phono preamp because that's the gray wire that comes in from there. So this is the phono preamp. We're going to leave that be. We're good here. We seem to be the same here. Let's come to the bases of the final output here. We got a signal of that size there, and we got a signal of that size there, which looks to me to be about the same. Let's look at our emitters. About the same there. About the same there. All right, so, yep, all right, so just over 4 divisions there. Slightly more here. So the change is obviously here. So let's take a look at our bases again, and let's kick up the gain on the scope so we can kind of see things better. So that's going to make it easy. That's exactly 2 divisions right there. Got a little bit of noise though. You can see it quivering there. It's kind of noisy. Now let's go to our other one here. A little tiny bit less there. So we got exactly 2 divisions there. And we've got a smidge less than 2 divisions here. So whatever is feeding these two, since it's already low on that spot there. Let's come back here. We'll go to the previous ones. So this is on the emitter there. And on the emitter there. And let's see if we can make this a little bit simpler. All right, so we're 2 divisions there. A little more than 2 divisions there. So right here is where we're starting to develop our problem. Because if we come to this previous stage here, and we're going to have to readjust our gain again, I got 2 divisions here, and I got 2 divisions here. This stage is cool. This stage here is developing a problem. Now, if we look at the bases again, we got a little bit less than 2 divisions there. A little bit less than 2 divisions there. So it looks like the bases of these devices are the same. Now on the emitters, we have a little more than 2 divisions. And on the emitter here, we have 2 divisions. So there's almost no gain here. There's a little tiny bit of gain here. So this may also coincide with one of these parts here that I was not getting. Yeah, like this one's super lossy. Like I have to go times 10 to see that one. And this one's not very much. So it could be that one of these capacitors, which is in the emitter circuit, which controls the gain, could be open, which would be creating, depending on the configuration, could be creating more gain or less gain. This one, we've already figured out that between base and emitter, there's almost no gain. There's maybe the tiniest bit, a little tiny bit. Here, there is no gain. Absolutely zero. So I'm looking at just a hair shy of 2 divisions there. And now it's changed again. Really? Really? We're going to do that? So now I have to figure out who's got more gain than who. So this is just over 2 divisions. This is just 2 divisions. And on the base we have just under 2 divisions and just under 2 divisions. All right, so the signal going into these is fine. The signal coming out of these, this one's a little bit hotter than this one. So again, trouble point here. This is the one that's got more gain. But that's not to say that we don't know who's supposed to have more gain than the other. That's the thing. But the fact that we have noticeable signal here and not very much here makes me wonder if C315 right here is open. And then the next question is this even accessible? Can we even get to C315? Now, Magnavox is pretty good about marking their stuff. So let's take a look-see. So I don't know if you can see it or not, but way down in there, in the shadows, there's C315. So that's on the cusp of where I can get something into. So let me check that with an ESR meter real quick, just out of curiosity. So this is going to be a really ugly shot because I have very limited space to get in here. Let's see, where was I just poking around? All right, so here's C315. And on the ESR meter, it registers about 2, which for a 10 microfarad of this vintage is about normal. Now, another thing I am going to do, though, is we're going to turn this back on, and we're going to see if there's any significant signal loss. I don't know if we can take a gander at the scope here, but I'm going to take a look at the signal loss through C315 if there's any, because we got signal on one side, about the same on both sides. So there's no real significant loss through there. I don't know if you can see it over there or not, but yeah, there's no significant loss through this part. And then if we look at the C315, just looks like a decoupler for the transistor there. So not terribly significant. There's another one over here. That's obviously not carrying signal. This is power supply voltage. That makes sense. So that pretty much is the end of my accessibility for that. We can just look at this one here. I think that was for the phono stage. So that's just wasting time there. And there's another spot down here. Yeah, so this stuff's tough to get at. So what do you do in this situation? Because it's not practical to troubleshoot, but yet the problem still exists. And obviously the only other one in that circuit that would be, close would be C319, but we can't get to that one. And I can't really see where it goes to because the board traces aren't visible. I don't have a schematic diagram, although I think I could get a hold of one. But that is, that's where we're at with this guy. What a pain. Let's check the voltages across these and make sure that they're both about the same. Because, we could have a gain difference because of, like I mentioned before, an emitter resistor or something like that that's gone wrong. So, base emitter junction here, let's make sure this is on. Yes, it is. So this is a Class A device, so we've got 3.2 volts across the base emitter junction. And with this other one here, about 3 volts, 3.0, 3.1. Ignore the negative because I'm just swapping my probes. So 3.2, so 1/10 of a volt maybe is going to change things. I don't know. I really don't think so. So let's start checking our resistor values around these
gain stages here. Like this looks like a meg, 0.63 meg, 0.62 meg, that's pretty close. Another meg here, 0.63, 0.623. So those are probably okay. We have a 22K, which has got a voltage on it, so can't really test that yet. Same with that. And let's see here. We've got what looks like a 2.7 meg. Hard to tell because, again, this has voltages on it. Let's see if I can discharge this somewhat. Always make sure it's off. Otherwise, you'll anger the power supply. Okay. Welcome to the world of real troubleshooting, kids. This is just how it is. Alright, so we got 25K. 24.8. 25K. So they're not off enough to mean anything. And so then let's see here. We got 2.7 meg going on 3 there. That's pretty significant. And then we got this one. That one's reading 2.88. That one's reading 2.998, so 100K difference. And it's not even in the stage that's affected, so I'm thinking no on that one. So it's probably still got voltage on it. It's supposed to be 560K, but I'm betting it has voltage on it. Yep, 100 millivolts. Let's see if we can drain that off. This is one thing that sucks about working with low voltage stuff, is that you're almost always going to have an instance where there's going to be a voltage right after turn on or turn off. That's going to be hard to get rid of. We're down to 12. That's bleeding down finally, but probably not enough. So this is where a VOM really helps because it's not so sensitive. Yeah, let me see if I can ground that out so we can get a little bit more accurate reading. But this is one of those things of annoyance. Yeah, so that's reading way lower. It's hard to tell what that is. And these should be 1Ks here. Yep. And that one looks good there. There should be a 10. That's 12. And then this one is 12. So they're both equally as off. So when you have a situation where all the resistor components look cool, you could start replacing capacitors and pray that it works. My thought is that one of these transistors has slightly more gain than the other since they're directly biasing each other. I don't think there's cap coupling between the two. So this is a bit of a conundrum because we don't know. Like this has no gain. This has a little tiny bit of gain. I'm guessing that there's supposed to be a unity gain buffer type thing. Now, one way you can kind of prejudge betas is do a base emitter check. So we have 0.689 and base collector check. Yeah, let's do the right thing here. 0.686, 0.689. The fact that those are really close together says that this has a very high beta. And if we come over here to this one here, get my head on straight, 685, 682, again close together. So it can be presumed that both of these are high gain. So yeah, we can try replacing this, but I don't think it's going to solve anything. I think that it's going to be a mismatch in beta with this gain stage here, because this is where our gain happens. These were cool. The bases of these were cool. The emitters were slightly different. They're an emitter follower configuration, so this is just an impedance matching thing. And the output of this didn't really look any different. I checked these guys already. I don't remember if I did. Let's put the meter on the correct setting. So that's 115K. Like this is 96K, and that's a little bit hotter. Settles at 115K, so this one's 15% higher than this one, but we really don't know if that makes a difference at all. You can experiment. Like for example, I'm going to shunt that resistor with a 47K and see if that changes our gain at all, just out of curiosity. And that will kind of tell us whether the amount that is off has any significant meaning. And I'm just going to go in here and touch this 47K to that resistor, parallel it, and we can see that there is almost zero change. In fact, there is zero change. So that's really not changing anything. And we can very quickly vary the emitter resistor value by shunting this with a 47K. This is probably going to piss things off. Not so much. Thought it would. It does very little. Unless I have a bad clip lead and I just don't know it. Yeah, not significant enough to matter. Let me go to this previous stage here. Yeah, so that does have an effect there. Makes me wonder if just simply adding a trimmer to this stage would help with things. So let's see if our frequency response changes at all. Yeah, so our lower frequencies, it's near the same. And if we raise it up, the gain difference really doesn't change too much, although it does. So let's try a more precise resistor value and we'll see if we can figure that out and maybe just trim it back a little bit. So I've been doing some experimenting, fast forwarding a little bit. And if we pad the output of the first gain stage with 15K, we get equal channels. And that's true of the entire frequency spectrum here. But we have equal gain, and I can change the volume control, and we still have equal gain. So really, this isn't the best solution, but this will make it work, and we're not burning a bunch of hours on troubleshooting. Because like I said, in order to really take this apart and get it so that it works well enough to do all the component troubleshooting would be horrendously long. We're talking 5, 6, 7 hours worth of time. And it's just not economically feasible to do that. So what I'm going to do is I just need a ground point, which could be the balance control, could be something else. I think there was something over here that would be considered ground. It's 1K off ground. Those are the emitter resistors for that. So nothing on the board adjacent that I can just tap into. There is the volume control up here, and then there is the center tap here at ground. So I might just use that point there. So let me install this resistor. I'm going to have to move the camera out of the way because my hands are kind of in the way of everything. But let's install the resistor, get it soldered up proper, and then recheck our work here. Alright, so I've got my 15K resistor soldered to the ground lug of the balance control, and then heat shrunk it and run a lead to the collector of that. And so now we see that we have proper gain, and it's at all frequency spectrums, so that's really good. And the volume controller doesn't care where it's at. The balance control doesn't care where it's at. I can center it now and it looks correct. So it's kind of a quick and dirty hack, but again, to pull this and to make everything perfect here would be stupid expensive. And people ain't made of money, and I just want it to work right more than anything. So now the fact that it behaves correctly, we can focus on the last thing, which we may or may not be able to do, which is the pilot lamp, which sits behind the front panel here. But again, this could be one of those things where you have to like disassemble 90% of the machine to get it. So to get the front panel off, you need to get a nut driver up in there, another one up in there, and there's a third one over at the end here. Let's see if that's even feasible there. Put this up on its end. Yeah, so that's, I don't think that that's reasonably doable. In fact, where is the lamp? I don't even see a lamp here. There's supposed to be a lamp here. Like a little dot or something. I can't even see up in there. And they got this glass so well tinted. Like if we go to the FM though, we get that nice, pretty red glow. So I wonder, like, how are we supposed to deal with that? Not sure if I can, at least not within reason. So what I'm doing is just shining a bright light through here and seeing where there might be a place for a light to come through here, but I'm not seeing any. We obviously have the ones for the dial, ones for the meter, ones for the stereo indicator. And all that stuff lights up there. But nothing along the bottom row here. It would indicate there would be a power indicator of some kind. So I'm not sure if there's supposed to be one here. I can't see any. It just kind of weirds me out because it's like, how else would you know it was on? Because unless the tuner lights are on, you just don't. You don't even know if it's on or not. Kind of makes me want to wire it so that the tuner lamps are on permanently, but that's another major change to the set. Yeah, so realistically, I don't see any other spot where light could protrude through to tell you it was on or not, so not sure about that. I also don't see a spot on the PCB where a light would go into, nor a hole here where it would shine through. So I think that just given that bit of information there, it's kind of hard to see, but there is no spot even for a lamp there. So the preamp problem has been solved, perhaps not in the best way that I'd like, but it is solved. The next thing I notice is that the FM dial is way off. We're picking up 98.5 at 100.3, and our stereo separation is kind of garbage. It's like non-existent. It's like, what, 10 dB or something? It's kind of crummy, so we need to go through that too. So that's where we're at right now. The preamp problem, such as it is, at least I can stick the balance control roughly in the center here, and we've got equal gains. So I'm kind of happy with that. I'm good with that. That switch is kind of dirty. Clean that. And just roll through it. I kind of think that the stuff for the light should be on all the time, because otherwise, how would you know? Maybe I'll ask him if he wants to do that. But anyways, nice happy looking preamp with equal gain there. So next part we'll be dealing with the tuner and some other stuff. So in any case, thanks for watching the video. More stuff to come.